So 1.23 shows velocity time graph for motion of an object. Compute the acceleration for each phase of the motion. See, one thing that you need to understand is, and we had done this in detail, but one thing that I didn't discuss because it was an initial lecture. One thing that you need to understand is, if this is my xy axis, this is x-axis, this is y-axis. Now on the x-axis I am plotting the time, and on the y-axis I am plotting velocity. One thing that you need to understand is, as long as there are straight lines on the graphs, so the straight line can look like this, or can look like these. As long as there are straight lines on a velocity time graph, all these are, Avantika, cases of uniform acceleration. Have we understood this?
Yeah.
See, these are cases of uniform acceleration. So for example, this is whatever the number might be. This is a case of a positive acceleration. This is a case of negative acceleration. Here acceleration is 0. Do we have any doubt about this? Avantika, do we have any doubt about this?
No.
See, why am I specifying this? Because very soon we might have cases like these. So this would be a velocity time graph, and this is how the graph would be given. And they will tell you, let us assume they will tell you that velocity is equal to t square, let us assume. And they will tell you what is the acceleration at time t is equal to, say, 2 seconds. Have you understood the question or not?
Yeah.
Aapka nahi hai syllabus. So basically what I'm trying to tell you is that this is what is the syllabus for class 9th. That in class 9th we deal with only uniform acceleration. And when we come to class 11th, this is what you are supposed to do, Avantika, where you are given cases of non-uniform acceleration. Avantika, have you understood?
Yeah.
And for calculating these kind of non-uniform acceleration, so for example, they'll ask you what is the acceleration at 2 seconds. So at 2 seconds, you will be required to find the slope of the curve at 2 seconds. Have you understood what I have said?
Yeah.
And for finding the slope of the curve at point P, I will require calculus. Specifically, I will require what is differentiation. Have you understood what I said, Vantika?
Yeah.
So in class 11th, our purpose is that we have to understand the cases of uniform acceleration. Though it has been discussed in class 9th. So in class 9th, first we understand what is the case of uniform acceleration. And then once we have understood what is the uniform acceleration, then we progress on to how to solve the cases where the acceleration is changing at every point, the cases of non-uniform acceleration. But for calculating non-uniform acceleration, you require calculus, and that is why in class 9th, cases of non-uniform acceleration are not used. Have you understood?
Yes.
Now what this implies is, of course, I'll come back to the question. There are few things that I want to cover.
Mm-hmm.
So all these cases that we are doing, we had discussed this in one of the lectures also. All these cases that we are discussing, they are close to Earth. Close to Earth implies that the acceleration is constant. So whenever they say that the ball is being thrown up or the ball is falling down, all these are cases that we'll be doing in equations of motion. So we'll be doing these 3 equations of motion after this topic. V is equal to u plus at. Have you seen the derivation of these equations of motion, Avantika?
Yeah.
So after this topic, we will be doing these questions from these 3 equations. What you need to understand about these 3 equations, and you should be very clear, very, very clear. Usually students, at least in class 9th, skip understanding this, that in these equations of motion, the acceleration is constant. The acceleration is non-variable. Avantika, have you understood?
Yeah.
Be very clear that for these equations of motion, acceleration is constant. And again and again and again, I am telling you, when acceleration is constant, it doesn't imply that velocity is constant. It doesn't imply that. It doesn't imply that. Let us try to relook this, because this also leads to a lot of confusion. So if you look at this, see, what I have said is, what I have claimed is that this is a case of uniform acceleration. The acceleration is positive. This is point T1. This is point T2. Have we understood this?
Yeah.
This is point T3. Between T1 and T2 and T2 and T3, the acceleration given by the slope of this line is constant. Do we agree to this?
Yeah.
This line has a constant slope, and because acceleration is given by the slope of the line, that is why the acceleration is constant. So the acceleration is constant. But if we look at the velocity, the velocity keeps increasing.
Hmm.
So if you look closely at time t1, the velocity is v1. At time t2, the point that I'm trying to make for the last 5-10 minutes is that this is where the maximum confusion of students is. This is a case of uniform acceleration, but the velocity is not same, and neither is the velocity zero, because on this line, at every point if you see, the velocity is increasing with time. Have we understood?
Yeah.
And if you look now again, if you look at a graph like this, now again when I say that acceleration is zero, why acceleration is zero? Because the slope is zero. But the velocity is not zero भाई. जो velocity है वो आप देखिए, ये देखिए velocity अगर आप देखेंगे यहाँ पर, ये देखिए velocity is constant. Do we see this?
Yeah.
Velocity is constant, acceleration is zero. But now when we look at this graph, let us look at this graph. Now as the time is increasing, Avantika, as the time is increasing, what you will see is that the velocity is decreasing. Do we see this? Decreasing velocity. Do we appreciate this?
Yeah.
So I have taken three cases with you. Case 1, case 2, case 3. Let me erase this. And what is happening in case 1, 2, 3 is 1, 2, 3. What is happening in case 1, 2, 3 is, in case 1, acceleration is positive, velocity is increasing. Case 2, acceleration is zero, velocity is a constant. In case 3, acceleration is negative and velocity is decreasing. Are we clear?
Yeah.
Any doubt till here?
No.
Okay. So now let us come back to the question, because one critical thing that I wanted to tell you, because the next topic that I will be discussing in this lecture is equations of motion. Now before I start even discussing these three equations of motion, is that the acceleration is constant. Acceleration is constant. I'll keep repeating, acceleration is constant. And the same, see, it will become doubly important for me, and I'll tell you why. Because I'll be using these three equations of motion for objects which are falling to ground, for objects which are thrown up. In that case, the acceleration at play would be gravity, acceleration due to gravity. And these objects would be close to earth. Have we understood? These equations of motion would be used in two cases. One would be the question that we will be doing now would be that there is an object on a horizontal ground and it is moving, say, right or left. That is one kind of question we will be doing. Another kind of question we will be doing is that there is a ball which is thrown up and there is a freely falling ball. In the second case, the g would be applicable, which is 10 meter per second square. In the first case, they will tell you the acceleration of the body, whatever be the acceleration of body. But in both the cases, these three equations of motion would be applicable. But we have to be very clear that in both the cases, the acceleration is constant. Avantika, are we clear? Or should I repeat again for 50 times?
No, this is clear.
Yeah, because this is a sort of point which usually students miss. Okay, now let us come back to, after all this nonsense, let us come back to the question. So, compute the acceleration for each phase of motion. We understand the one second. Avantika, what I'll do is I'll restart the meeting. Yeah, just
Yes.
join within 30 seconds. I'll restart.
Yeah. Yeah. Okay.
So, 1.23 velocity time graph is given to us. Velocity time graph is given to us. Acceleration for each phase of motion. So, the good thing to do is, so let us assume this kind of question comes in your MCQ. The good practice that you can follow is, one is that we have OA, AB, BD, DE, EF as the 5 phases that the body is undergoing. Have we understood this?
Yeah.
Okay. Now there are few things that we'll try to understand using this graph. Now when you look at this, the good practice that we can follow is we can label the points. So this is 0, 0. This is 0, 1, 0.
Mm.
Yeah, now it is making sense. So this would be y2 minus y1, y2, this is y2 minus y1 upon x2 minus x1. Are we clear?
Yeah.
Any doubt?
No.
Let us look at slope for AB. This would be y2 minus y1 upon x2 minus x1. BD would be y2 minus y1 upon x2 minus x1. DE would be y2 minus y1 upon x2. DE x2 is 9. x2 minus x1, and for EF it would be y2 minus y1, y2 minus y1 upon x2 minus x1. Are we clear?
Yeah.
जी बोलिए. I'm sorry. कौन सा? अच्छा, आप वैसे करना चाहते हैं, ठीक है. अगर आप ऐसे करना चाहते हो तो ऐसे कर लीजिए. BC देख लीजिए. तो दिस वुड बी 5, 0. So BC would be y2 minus y1, y2 minus y1 upon x2 minus x1, and CD would be y2 minus y1 upon x2 minus x1. ठीक है मैडम? ठीक. So now let us see what is the answer that we get. So this would be 0. This would be 8 by 3. BD now we have divided as a BC and CD. So let me erase this. And let me calculate BC. BC would be minus 8 upon 2. Am I correct? So this would be minus 4. This would be minus 20 upon 5 would be minus 4. जी. I'm sorry? जी. y2 minus y1 upon x2 minus x1. जी. y2 minus y1. Oh, minus 0 है भाई. Sorry. Sam जी, thank you. y2 minus y1 upon x2 minus x1. अभी ठीक है ना? जी, अभी ठीक है? फिर से देख लो, y2 माइनस y1 अपॉन x2 माइनस x1. हाँ अभी ठीक है श्याम जी, ठीक है भाई. डाउट है तो बोलिए, शायद मैंने गलत किया. आई थिंक ठीक है. सो दिस वुड बी माइनस 12 अपॉन 3 which will be equal to minus 4. Avatika, is it making sense?
Yeah.
Hmm?
Yeah.
And of course, see, so Sam is absolutely right, because this has to be minus 4 and this has to be minus 4, because we are talking about this line BD. But BD should have the constant slope. So that is why the slope of BC should be equal to the slope of CD. So that is why the constant slope of minus 4 is there. So, have we calculated everything? Yeah. So this is 0 meter per second square. Our AB is 8 by 3 meter per second square. Our BD is minus 4 meter per second square.
1 second, sir.
Yeah. Yeah.
AB, why are you getting 8 upon 3?
I'm sorry.
No, for me, I'm getting 4. I'm getting 8 upon 2, giving me 4.
Yeah, you are right. This is 8 upon 2 is equal to 4. You are right. Correct. So this is 4. Are we clear?
Yeah.
So DE is y2 minus y1 upon x2 minus x1. So this would be equal to 8 upon 1. This is 8. Is it correct?
Yeah.
And EF would be y2 minus y1 upon x2 minus x1. So this would be equal to 0, and of course the slope of this line is 0. Are we clear?
Yeah.
So now, you know, one thing that we have understood. Let me note this down. Just give me a second. This is 0, this is 4, this is minus 4, this is 8, and this is 0. Now I can erase this. Yeah. So now there are few things that we can understand. This is 0 acceleration and 0 velocity.
Yeah.
0 acceleration and 0 velocity. But when we look here, this is a constant acceleration of 4 meter per second square, but it doesn't imply that the velocity is same. As you can see, the velocity is increasing. When we look at BC, again from B to D, if you look at B to D, if you analyze the motion, so from this graph we are trying to understand lot of things. So from B to D, the acceleration is negative. It is retardation. The velocity of the body had increased to 8 meter per second. It started retarding. At this point, let us analyze. At this point, what would have happened is that the velocity would have become 0. Then the velocity became negative, because velocity is vector. That is why now the body has started coming back to where it has started. So this is how the body would have behaved. This is from point A to B. Here it was moving this side, and then it started retarding. It was in the same direction because the velocity is positive till point C. At point C, it came to a stop. From point C to point D, it changed direction. Why?
Yeah.
Because the velocity is negative. Sam ji, good out. You पीछे आ गई, नहीं समझ में आया. So it increased the velocity. It increased the velocity. It increased the velocity in the negative direction. Now we come to phase DE. In phase DE, it in the negative direction, it increased its velocity to minus 12 meter per second. Then from D to E, it slowed down, but it kept moving in the negative direction. It slowed down to minus 4 meter per second. Are we clear?
Yeah.
It is still moving in the negative direction. But now it has started slowing between D to E. It is moving in the negative direction, but it is slowly slowing down from minus 12 meter per second to minus 4 meter per second. Then between E and F, it is moving in the negative direction with a constant velocity of minus 4 meter per second. That is why if you see the acceleration, that is why if you see the acceleration is 0. So at the final point, when we trace the body at 11 second, it was still moving in the opposite direction with a minus 4 velocity. Have we understood this? Now there is another thing that I wanted to share with you regarding this, using the same graph, because you will be solving those kind of questions also. So one thing that I wanted to share is, there are two things that they can ask you. One is, they will ask you what is the total displacement, and another thing they might ask you is what is the total distance covered. Have we understood? Have we understood the question?
Yeah.
Now if we understand the the fundamentals well, the basics well, distance is always positive. That is why the distance would be added when the object was going in this side, as well as when the object came back, when the velocity is negative. The distance would be added, because distance is always positive. ऑटो वाला आपके घर से स्टार्ट हुआ, घूम फिर के आप वापस आ गए सब्जी लेके, ऑटो वाला पूरा चार्ज करेगा, दो योर डिस्प्लेसमेंट इज 0 बट डिस्टेंस इज ट्रेवल्ड. नाउ हाउ डू वी कैलकुलेट द डिस्टेंस? वी कैलकुलेट द डिस्टेंस बाय adding this and adding this. Have we understood?
Yeah.
Now that is why I wanted to spend some time on this question, because there are a lot of things that you can learn from this question. Most of the things would be covered regarding the graph in this question. So this would be the area of a triangle, or what you can do is, this is the base of the triangle, this is the height, and
Sir, your voice is breaking.
Is it clear now? Is it clear now?
No, it's still not.
Is it clear now?
Yeah.
Okay. So if you look at this part of the motion, Avantika, 1 second. Am I audible? Avantika, am I audible?
No, sir, voice is going. I don't know.
I'm sorry.
Yeah, now I can hear you.
Yeah. So if I have to find the area of this part of the curve, this will be given by half base. Now from here to here, this is 5 minus 1, 4. Understood?
Yeah.
So it is not 7, it is 8. I think I spoke 8, but I wrote 7. I think this is what happened. So this would be equal to 16. So this is the distance which is traveled in this part of the graph. Now when I look at this part of the graph, this is the area that I have to cover, and this would be equal to half base. Base is from 5 to 8, half base into altitude. Altitude would be 12. Is it making sense? Avantika, is it making sense?
Yeah.
So this would be 18. And then if you see closely, this would be a trapezium. Do you see this trapezium?
Yeah.
If you remember, in last lecture we had discussed the area of a trapezium. Area of a trapezium is length of the sides, basically length of the opposite sum of the lengths of the opposite side. These are the opposite sides. If we want to calculate the length of these, it is half of 4 plus 12 multiplied by the distance between them. The distance is 1, so the area would be 16 divided by 2, it will be 8. Is it making sense?
Yeah.
And then we can calculate the area of this rectangle. Finding the area of this rectangle is simple. What we will do is multiply 2 by 4. So the answer would be 8 meter. Are we clear? Yeah. and we can add all these up, and then we can find the total distance. So this is how we find the total distance. Avanti, are we clear?
Yeah.
Now the interesting thing which happens is when we have to find the displacement. That is where the interesting things start happening. Because the interesting thing would be that you'll have to, when you do this process, this part would be positive. This is 8. This part is positive, and this whole part would be negative. Have you understood?
Yeah.
As I can see, and when you calculate, you'll have to do the calculations again for whole of this. You'll have to, at least for the distance displacement part, you'll have to do the calculations, because I think your acceleration things are done. The acceleration values are fine. So for distance displacement, you'll have to do the calculation. Now, as far as I can see, and it is pretty visible, that this area would be less than this area. Have we understood this?
Yeah.
So this is how the body would have moved. Like, it would have gone to, let us assume, on the right side, and when it came to the left side, it overshot the starting point. That is why the net displacement is negative. Is it making sense?
Yeah.
So all this information we can have just looking at this graph. Is it making sense?
Yeah.
Great. And I think what we can do is, now this is a difficult question, just try to do a easier question. This is a easier question. You can do this. Problem 1.5, you can start.